Good afternoon, everyone. This is fantastic, actually. Normally at conferences, people don't talk to each other. Now I'm having to get you to shut up or to listen to me. But you can carry on talking amongst yourselves. That's good. That's an important part of the conference, too. Yes, welcome to one of the last formal sessions, I guess, of the day, Java 8 in anger. Now, I shouldn't actually have to explain what that means in the UK, but I've been giving this talk around the world, and apparently lots of people don't know what in anger means. And they thought that I was typing Java 8 really angrily, like it was really awful. And that's not what it means, for those who are not necessarily native English speakers and Americans. Java, it means, apparently, I didn't know. It means Java 8 in practice, Java 8 in real life. So the point here is I've been going to a bunch of conferences and I've read a bunch of books. So you see kind of Java 8 features used like in slideware and on books. And what I really wanted to do was sort of see what it felt like to work on it as a real developer on a real application and kind of show that to you guys. So Java 8 has one or two new features, just a few things snuck in there. Don't see why it takes so long to do a major release, if I'm honest. And there's a bunch of things like concurrency and loads of garbage collection stuff and mission control and loads of fantastic stuff in Java 8. But probably you and I, when we think about Java 8, probably what we're thinking of is mostly Lambda expressions for these funny arrow braces things, and streams, the new Streams API on the collections. So these are the two things I think most people think about when they think about Java 8. So what I want to do, like I'm saying, is I want to show you how to use these features, along with a couple of other Java 8 features, in a real-world application. So live coding with all attendant danger, and coding up an application which may look sort of more similar to something you see in your day jobs and not necessarily just the toy code you see on slides. This real-world application will be a JavaFX Twitter dashboard, because these days it's all about live streaming data and listening to the Twitter fire hose. So, who am I to deny that trend? So I'm going to display information gleaned from the Twitter fire hose on a JavaFX dashboard. And the reason I've chosen JavaFX for the UI, even though probably, I don't know, most of us probably don't really think of Java as a UI language these days, no idea why. I picked JavaFX because I can carry on using Java 8 stuff in JavaFX. So I can carry on using Lambdas and streams while doing UI coding. So I don't want to switch between JavaScript and Java. I want to stick in Java and show those features. You might pick up some JavaFX stuff along the way as well, but this is definitely not a JavaFX tutorial. So this is kind of the overall architecture of our application. I will go through each piece in detail, so I'm not going to talk you through the application architecture as it stands right now. I have a number of independent services that are running in the backend. They are very small services. One might call them micro-sized, but I didn't want to put that into the blurb because then people think this is a microservices talk, and it's not, because these are not resilient services. They don't come back when they die. It's just more of a way of figuring out how to design your application in terms of small independent services rather than a full-blown microservices talk. If you want to, you can have a look at the code and even play along as you go. If you want, all the code is on GitHub. This URL will be up at the end as well. So when I skip through this really quickly before you get a chance to take a photo, you will see it at the end too. So all the code is available. If you look at the master, that is the full completed application. If you look at individual branches, you can see there's a branch called skeleton, which is like the empty version of the code that I start with here. So you can actually, if you wanted to, you could build it up the same way I build it up in this talk. So, without further ado, let's make a start. The first thing that we want to do is we want to display a leaderboard of the top tweeters. So let's say we're subscribed to the conference feed, for example, looking at the hashtag for DevOps UK, and we might want to see who are the top people who tweet most frequently on that hashtag. So what we're going to do, you can kind of, what a leaderboard looks like. It's tabular information. We have a Twitter handle on the left-hand side and a count, the number of times we've seen that Twitter handle tweet something on the right-hand side. So it's a fairly simple table of information. We're going to be listening to a stream of data and basically sorting it and filtering it for this widget, if you like. The first thing we're going to do is I'm not going to connect to Twitter and do the whole back end just to display the UI to begin with, because that's not really particularly interesting. It's also not necessarily the best way to drive out your UI design. So the first thing I'm going to do is I'm going to create a stub service, which is going to emit Twitter handles periodically. So then I can build my UI based off this stub user service, and we'll come to building the user service later on in the talk. But to begin with, let's put this in place so that we can build up our UI widget. Oh no, I knew I was going to do something wrong. That is illegible. This is where you get to see me mucking around with IntelliJ. Oh, that made it way better. I don't normally have a high-resolution screen. Normally when you're projecting on here, you get like low resolution and you get the nice font to begin with. I'm going to have to put this up to size like 5,000 million. Honestly, it's not like I work for the company that makes IntelliJ or anything. Fantastic. This is just typical, isn't it? You know what? I might restart IntelliJ. Hold on a sec. So this is a live demo with real live code, and things always go wrong. That's the first time that particular error has been seen. So yes, talk amongst yourselves while IntelliJ starts up. Yeah. Where's the picture from? Oh, I took that at QCon. Yeah, I took that, Westminster Abbey? I took that at QCon the year before last. It was actually sunny in March in London, so I had to take a photo. Oh, well, that's kind of better. In a completely illegible for a different reason way. All right, let's put that down to something slightly more sensible. Apply. All right. So nowadays I use this Microsoft Surface, which is fantastic and brilliant, and I really like it. But every now and again, that combined with all my technology doesn't work. Anyway, let's not blame Microsoft because they are here. Fine. What are we doing? We're doing a stub service. So user test data. What I'm going to do is, when I can find my cursor, it's like at such high resolution, it's the smallest thing in the world. What I have is, I have a string of fake Twitter handles. So obviously I'm going to, a string array of fake Twitter handles. So you can tell they're fake because this little error is not going to go away. Go away. You can tell they're fake because obviously they're 3 characters. What I want to do is my stub user service is going to randomly pick one of those Twitter handles and emit it like every half a second so that I can kind of respond to that and write test stuff off the back of it. And this is where we get to see our first Lambda. So I have a stub service class which takes care of all, I'm using WebSockets under the covers, and it takes care of all the WebSocket stuff. In terms of the business logic for my stub service, all it really cares about is the path that it's going to be running at, the port it's going to be running at, and the business logic for this stub service. Now, the business logic for this stub service is basically randomly pick one of those strings and publish that periodically. So we can see here already, Java 8, by allowing me to pass in the business logic as a simple lambda, allows me to separate the infrastructure side of stuff and the business logic side of stuff, so that my stub service is kind of the simplest, stupid little class you've ever seen. I've written Hello World apps which had more code than that. So let's run this. So we'll have our service running on the back end. Okay, so I have my I have my user stub service sat there at the back end emitting these Twitter handles periodically. So obviously the next thing I want to do is I'm going to build the code which is going to connect to that service, look at those Twitter handles, and figure out how to display them on a leaderboard, how to sort them, how to filter them, how to display them on the leaderboard. So this is where we're going to get onto the UI side of things. So this is a JavaFX UI. If we've done sort of applets or swing coding before, this is not enormously unfamiliar, but like I say, this is not a JavaFX tutorial. All you really need to know is that you're going to have some sort of application, you have a stage, and you have this kind of like boilerplate stuff, I guess, to kind of get you started, to launch a window, and so on and so forth. What I do have is there are different ways of creating your UI in JavaFX. You can create it using fxml, or you can create it using Java. I've chosen to use fxml because although normally XML is not my first choice of programming language, by using fxml to define just the view bit, that gives you a really clean separation between your view, your model, and your controller. I mean, anyone who's worked on any sort of UI side of stuff knows how easy it is for your logic to creep into your view code, especially if it's in Java. So by kind of putting that into the fxml, I'm kind of forcing you to say, look, if you want to do anything complicated, you have to do that in Java. So you have to do that probably in the model or the controller somewhere. And we'll come back to what that looks like in a minute. What I do want to do first up, obviously, is I need to connect to my Twitter service to kind of consume and parse these tweets. So I need a client endpoint. So client endpoint is a class I've created, which you can look at in the code if you want to. I need to give this an endpoint to connect to. So I have a URI. So I've just coded that into an IntelliJ live template because otherwise I'm going to type it wrong every single time. So all this does is I'm going to connect to my stub user service, and then I need to do something with that. So this is my user endpoint. So what I'm going to do is I'm going to add a listener to that endpoint, which is going to listen for messages. In this particular case, the messages are Twitter handles. So my listener is going to be leaderboard data. So I talked about trying to have a separation between the MVC. I have a leaderboard data class, which is going to be effectively the model. So it's going to sort out what data to show on the screen. Now, IntelliJ is telling me, oh, look, you can see exactly what IntelliJ is telling you. I happen to know it's the last thing, that leaderboard data needs to implement message listener. So we'll just make it implement message listener, which means we have to create this onMessage method. So this message, just to be clear, this is our Twitter handle. So what do we want to do with our Twitter handle? Well, we have a hash map of all the Twitter users we've ever seen, which could potentially get big, but let's not handle that for the time being. This is a demo. But what we're going to do is we're going to map a Twitter handle, the string of the Twitter handle, to a real Twitter user type of object. So we're going to put those in the map. Now, in the olden days, one of the things we had to do a lot with hash maps is we have to look to see if that key exists in the map. If it doesn't exist, create the value that's going to be associated with that key and put it into the map. So we'd have an if. So I'm going to get the value out. If it's null, create a new thing, and then poke it into the hash map. Now, in Java 8, that's a lot simpler. We have a method called compute_if_absent. And so this takes the key that we're looking for. In this case, this is Twitter handle. And it takes what's it called? Oh, it's a function. It takes a function which is the function that you're going to call if that doesn't exist. So how am I going to create the thing to put into the map if it doesn't already exist? In my case, let's see what this looks like. I'm going to expand it out into an anonymous inner class because I'm not super familiar with the way that Lambdas work right now. The method signatures are kind of magic, and I'm not really sure what types I'm returning or getting or passing in. So if I expand this into an anonymous inner class, I see something which is much more familiar to me. I can see that it takes a string, which is the type of the key for the map, and it returns a Twitter user, which is the type of the value. So given a key, how do I figure out what value needs to go in there? So in this case, all I need is a new Twitter user with this particular Twitter handle. Now, because IntelliJ is awesome, by the way, I do work for JetBrains, It's awesome anyway. It gives me a suggestion which you can't read because it's tiny. I have the option of replacing this with a lambda or replacing it with a method reference. If I replace it with a lambda, then it looks something like this. But a method reference is even shorter. So I replace it with a method reference, and then suddenly what I'm giving this compute if absent method is, this is the key. If there's no value in the map associated with that key, call this method to create the thing to go into the map. So then this will give me a Twitter user, either the existing one that was in the map or the new one that we've just created. So now I have my Twitter user. I'm just going to increment the number of times I've seen it. And then what I want to do is I want to look at all of our Twitter users that we've seen. I want to reorder them in descending order so that I have my most frequently seen one at the top of my list. And I want to limit it according to the number that I'm going to see on the screen. So we can do that with streams. So first I'm going to get the values. So I want to know, I'm looking at the Twitter users in this map. I'm going to get the stream. So I need to sort this. I have to remember what it is, sorted, yes. I need to sort this. Now, this takes a comparator. I mean, probably everyone here has written a comparator at some point, and what you get is you get something which looks something like this. You get object 1, object 2. You have to, like, minus 1 from another, and you're not sure whether you're minusing 1 from 2 or 2 from 1, and it kind of, you have to have tests to make sure your comparator works properly. But actually, there's a much easier way of doing this in Java 8. I can actually say, I can pass in the method I want you to compare on. So I can say comparator.comparing, and what I want is the Twitter user get tweets, which is the number of tweets this Twitter user has tweeted. So, and I need to sort it in reverse order, so I say reversed. So comparators become a lot simpler to work with, particularly when you're sorting things in streams. Let's get that out of the way. So let's even static import that to remove that. So my phone is making noises. How embarrassing. Everyone turn off your phones, including me. So what I want to do is now I can say I'm sorting it by this getTweets method on the Twitter user. I've sorted it in descending order. I need to limit it by the number that will fit on the screen, which happens to be this number. And I'm going to put these into a list. So I'm going to collect it into a list. So let's put this into a list. These are my top tweeters. And yeah, my formatting is kind of screwy in this size, but you get the idea. So the last thing I need to do is I need to put this list that I've just created, which are the top tweeters I want to display on the UI, I need to put them into some sort of UI holder so that the UI knows that these are the things to display on the screen. And I've got a list here, items, which is an observable list. So that's the way JavaFX is going to look for changes in what needs to be displayed on the screen. And I'll show you what the view looks like in a minute. But what I need to do is I just need to set items so that it's equal to this new list that I've created. And that should be the simplest thing that we need to do. That should be all we need to do. But in actual fact, this observable list is an object which is being used by the UI thread. And this onMessage is used by a separate thread which is listening to messages from the back end. So I can't manipulate the items array on this other thread, because then you basically get the equivalent of a concurrent modification exception. So I need to tell the UI thread to run that instead. So I do that by saying platform.runLater. I need to give it a lambda. I could give it a runnable, but we're in Java 8 land. So I give it a lambda. And I say, basically I say that's how to tell the UI thread to do this bit of code. So you can see it's much shorter and much easier to pass behavior around between individual threads. So that's this is our data side, our kind of business logic for our Twitter leaderboard. We need to display it somehow on the screen. So all right, so we need to connect to the back end first. Let's make sure we connect to this. Otherwise, we're not going to get anything. I need to wire up. I have a controller and a view. The controller is the bit that's going to glue the view to the data. We'll have a look at that in a minute. And I have the view is going to be leaderboard fxml. So this is associated with this leaderboard controller. My controller is really simple. All it is it kind of tracks this table view, which is the representation of the view of the UI, and it's going to get those items that we just set in leaderboard data and put it into our tabular information. So what I need to do is I just need to configure this here. So I'm going to have a table view. It's going to have an ID. IntelliJ suggests what ID that's going to be. It's going to have a height. It's going to... I'm going to mess that up. It's going to have some columns. I'm going to change my indent to something more sensible. I'm going to create some individual columns here. So I've just created a live template in IntelliJ to do all that typing for me because I didn't want to type everything, but it's a reusable piece of code. So here I'm going to type the text which appears at the top of the column, which is Twitter handle. It's going to be associated with a Twitter handle property, and the width is going to be 300. I'm going to do the same thing for the number of times we've seen that Twitter handle tweet. So this is count tweets, and the width is, I think it's like 180, something like that. So that's how we define our UI in JavaFX. We just kind of, I didn't think that XML was a sensible language for defining the UI, but then, of course, I realized it's exactly the same as HTML, so it's not massively unfamiliar. Then we should be able to start our UI up, preferably without error. Let's see what happens. Oh, it's tiny. These high-resolution screens are amazing. But anyway, you can totally not see, but what you should be seeing is on the left-hand side, you're seeing these fake Twitter handles coming from my user service. You're seeing the count increment. There's a number of different things happening with the UI here. One, if the count increments, then that value in that box changes. And two, if a new value comes in, it also gets added to the list. Also, they get reshuffled if the values change, so 3 goes to 4, it gets reordered and shuffled up. One of the things I can do, which should make it slightly more visible, is I can change the size of the font on that. So we're using CSS because it took us 12 years to figure out how to use CSS, so we might as well carry on using it. So I can use CSS to style this. JavaFX has its own CSS properties, but you can kind of see it's something that we're kind of familiar with if we've been using CSS. So here I want to set the font size to 20, and then I'm going to, hold on a second, figure out where my buttons are, and restart my UI. It's marginally more visible. Usually, in a normal projector, that takes up the whole screen. But in a high-resolution screen, not so much. But anyway, you can see it's reacting to live data coming back from the service, redrawing the screen. I didn't have to do anything enormously complicated to get JavaFX to do that. So let's move on to the next thing. Let's look at the moods of tweets. We want to see if overall the tweets about, let's say it's the conference, the tweets are generally happy, generally sad, or maybe they contain a mixture of both emotions. So this will be, we're going to display this in a pie chart. So green for happy, red for sad, yellow for I'm not really sure what mood I am. And similarly to the user side of things, I need to create a stub service to emit these different moods. What the stub service is going to do, if I show it to you, is there are 3 different things it can send out. So happy, sad, or happy, sad, if it contains both. Obviously, you can see this being expanded to be more complex mood analysis, but I'm just going to do happy and sad to begin with. And I do the same thing as I did for the user service. I'm going to randomly pick one of those 3 values, and I'm going to publish it. But again, I'm running this service completely independently, so it's yet another service running on the back end. It's running at a path of moods and a port of 8082. So let's start this running. So now you can not really see because the font is so tiny. We have a mood service running. We still have our user service running. And we have our dashboard running as well. So we've got 3 things running in the background. Like the leaderboard, obviously we need to create the model view controller, which is going to parse these moods, do some sort of analysis on them, and then put them into a pie chart. So we're going to go back to our dashboard. We are obviously going to connect to this new service. We want, I do not remember what I want for this. Oh, TweetMood. And this is going to be slightly more complicated than our previous endpoint. Our client endpoint for users doesn't do anything complicated. It receives a string, which represents Twitter handle, and doesn't do anything to it. It just uses that Twitter handle, which is totally fine. We want to do something a little bit more complicated with the mood, because we need to separate those comma-separated values out, so that if it's a happy and a sad, we get the idea of these 2 different moods. So first we need to connect it to a server endpoint. So that's where we said it was going to go. We need to give it a message handler. This is the bit which is going to take the strings and turn it into, we said we wanted a TweetMood object, a real object. So I have something which is tweet parser, TweetMood. Oh, I can't remember what any of these things are called. Mood parser. And I can parse the message being this comma-separated set of values. So this is the behavior I need in the client endpoint. It's going to take a string and return some sort of tweet mood. So IntelliJ, again, suggests we can just replace that with a method reference. We don't have to worry about any of that stuff. We just say, look, when you get one of these moods in, call this method. We'll end up with this being our mood endpoint. And we need to add a listener to this as well. So we'll add a listener. This listener will be the mood chart data. And again, we will get that to implement message listener. And so like the leaderboard data, we're going to have it listening to these messages. This, instead of being a Twitter handle, is this tweet mood. So when we see one of these tweet moods, what do we need to do? Well, if it's happy, we need to increment the happy portion. If it's sad, we need to increment the sad portion. And if it's both, we're going to increment the confused portion. But actually, if it's both, we're also going to increment the happy portion and the sad portion, because I said so. I mean, someone asked me, why did you choose that? Well, I don't have a business analyst, so I arbitrarily decided how I was going to do that. So if the message is happy, then I'm going to get this happy portion. These piechart.data classes, this is part of JavaFX, so that's just kind of the representation of that pie chart. So my happy portion, I need to set the value to be the happy portion, get value, +1. If anyone can spot the potential race conditions and concurrency problems in that, they get extra brownie points. And I need to do the same thing for the sad portion. I can't type and talk at the same time, so amuse yourselves. And you're all probably thinking, surely, since you've had to type the same thing 3 times, surely that's ripe for refactoring. And you're absolutely right. It is ripe for refactoring. So here's where we're going to start to use IntelliJ's amazing refactoring tools. If you're not using IntelliJ, you should be. So let's refactor this into a method. If anyone's got sharp eyes, they'll probably see that down in the bottom middle in green, IntelliJ is kind of actually flashing up which keyboard shortcuts I'm using. So hopefully they're subliminally embedded in your brain so you can remember what they all are. So we're going to call this increment pi. And we're going to extract out the stuff that's specific to happy. So let's pull this out into a parameter. We're going to call this criteria. Let's extract this out into a parameter. Both bits of happy, and we're going to call it portion. Now IntelliJ picks up that now I've made those changes and made it more generic, that I can actually just refactor those 2 bits of code. So now I only have like 3 method calls that look the same instead of 3 bits of code that look identical. But actually, you can go one step further if you want to, and this will be very much dependent on the business logic that you're looking at. But let's say, instead of saying I want to pass in the criteria and I want to pass in an object for you to do something on, let's say we pass in the do something on bit, the do something bit. And so this is where we start to write our own methods which use lambdas, effectively. So I can use Control-Alt-Shift-P, catchy, to extract a functional parameter in IntelliJ. IntelliJ is going to suggest a functional interface which matches this signature with the right parameters, with the right return types. In this case, I'm not taking any values and I'm not returning any values, so runnable is a sufficient interface. So I'm going to extract this out. Let's call something to do. So now what we do is, all we do is we take this runnable and we call run. That will be the thing that we do. And then we can just get IntelliJ to turn this into lambdas. Now, the interesting thing about this is because it extracts it automatically as anonymous inner classes, you can start extracting functional parameters in your code now, even if you're not using Java 8. So you can start refactoring to these patterns. Granted, anonymous inner classes are not super pretty, but it's a way to start thinking about how maybe you might start passing these bits of behavior around before you start using Java 8. So here what I've done is I've extracted out this lambda to pass into the method. I would argue that in this particular case, it doesn't really give us that much because we still sort of have this repetition. But if maybe we wanted this method to be a much more general do something method, which was kind of called in a bunch of places, maybe this might be useful. But if you're sort of thinking about these sorts of patterns, then you need to be thinking, am I getting the benefits or am I not? What are the pros? What are the cons? In this particular case, I'd say there's probably no benefit in extracting that lambda out. But in other cases, there might be more benefits in extracting out the behavior. So now we have our business logic, our data for figuring out which bits of the pie chart to increment when we get a new Twitter message. We're just going to wire up the rest of the bits. Firstly, we are going to connect to the backend. That would be useful. We are going to uncomment this, and we're going to create our pie chart, or not. So this is connected to a mood controller. Our mood controller it has a pie chart. It glues the data to the view, the same as the other one. So we need to create a pie chart. So here we have a pie chart. This takes an ID. IntelliJ picks up that's the name of the thing in the controller. I'm going to give it a title, which is overall mood. And that's all I needed to define my pie chart in JavaFX. So now, if I rerun my dashboard, let's see what we get. Great. So we now have our pie chart reacting to new moods as they come in. It's incrementing the right pie for that. We should see, because we're sort of we're randomly picking between the 3 values, we should see it more or less even between those 3 different values. The only thing I want to do is, I don't really like those colors because happy's kind of murky orange. Sad is red, which is fine, and my confused portion is kind of green. And we're not aiming for people to be confused, so I don't really want them to be green. So once again, we can use JavaFX, we can use CSS for this. So I can say, instead what I want to do is, I just want to swap those colors around. So that's the definition for my colors. Let's restart our dashboard. And then I get the colors I want. So it's super easy just to figure out how to reskin this without really doing anything. So the last thing we're going to do on the UI, before we start looking at some of the interesting bits of the back end, is we can use that same mood service, but we can track moods over time. So the pie chart is obviously kind of showing overall mood, but what I want to see is, are we getting happier? Are we getting sadder? How does it go over time? So I'm going to track this with a bar chart. I could use a line chart or whatever. But what I want to do is I'm going to see for each minute what was the level of happy for that minute and change it over time. Obviously, we can reuse the same service, so I'm not going to have a different service for this. I'm just going to listen to the same messages, but do something different with them. So here I can just connect to the same backend, add a new listener. This listener will be my happiness chart data. Happiness chart data happens to implement the right message listener because the on message wasn't super exciting, so I just implemented that. What I do want to do, though, is, so what we have is, let me show you here. What we have is, we have a bar chart, and we're going to show, this is going to be the bar for like minute 3, minute 4, minute 5, minute 6, and we're going to increment each of those when we're in that minute and we see a happy tweet. But what we need to do is we need to initialize all of those to 0, otherwise we're going to get a null pointer exception when we try and increment the right one. So in the olden days, well, firstly, let's have a tiny, tiny peek of new date and time, because new date and time is awesome. Thank you, Richard. So we'll get we'll get now from local date and time. What I love is the fact that there's a method called now, and it's really clear that what you get is the time now, which is nice and sensible. Not only do I want the time for now, what I specifically want is I want the minute. So I want the minute of 36, because it's 36 minutes past. What we would have done previously, I need to iterate from now until 10 minutes in the future and set all those bars to 0 for the next 10 minutes. That's just kind of how I want to do it. So we might have done something like this in the past, where I say minute plus 10. Let's get rid of that. This is from minute. And I'm going to call initialize bar to 0 for I. Okay, so that's the sort of thing, that's the kind of code that we've written millions of times before. There's another way of doing it under Java 8. I can say int stream. I can have a range from this minute until minute plus 10, so 10 minutes time. And then I'm going to say, for each one of those, call something. So I'm going to call initialize bar to 0. So it's the same thing. I believe there are different performance implications of the two different methods. I'm not sure. If performance is important, as always, measure first, don't guess. But I think here the interesting thing would be more around usability, readability for your team. So if you're used to reading for loops, this might be a bit like, I have no idea what's going on here. But if actually you think that maybe everyone in your team is kind of comfortable with this and you like the fact that it's a bit more succinct, then maybe you'll go for something like this. So you have more options open to you now, I guess is what I'm trying to say. So now we've done our initialization here. We just need to go back and wire everything up. We are going to glue our controller to our data, and we're going to create our bar chart. So again, what does our happiness controller want? Our happiness controller is looking for a bar chart. That's a surprise. So here, let's create a bar chart. We will associate it with that. We'll give it a title. We need to, it's going to have a y-axis, which is going to be the count. And we're going to have an x-axis, which is going to be the minute. So now when we go back and rerun our dashboard, we should have a new widget. I've lost my mouse. Okay, so we've got our new widget in the bottom corner there, which is counting every time it sees a happy tweet. It's counting it for the minute because it's 39 minutes past. It's putting it in under minute 39. There are lots of other things I could do to make that chart prettier. This is just the default chart out of the box. I've done like no tweaks to it, but I can get rid of the legend because I'm not using it. I could take away the animation on the bottom x-axis so it doesn't flicker. I can do a bunch of stuff there. I could set the axes But at the moment, I'm just leaving JavaFX to take care of all of that stuff automatically, and I don't have to worry about any of it. And I get a rough idea of the information I actually want. The only thing I do want to do is I want the bars to be green, because that's associated with happy. So let's just quickly change those to be the right color. Not table, that's not right. So obviously here I'm just going to set the color to green. Okay, so what we've got here is we've done the full UI. We could do all sorts of tweaks to this if we want to, but we've done a really basic UI fairly quickly. It's using Java 8 features such as lambdas and streams to kind of help parse these bits of data coming from the back end. I have 2 stub services feeding it with data, but this is kind of the UI more or less finished in its first iteration, if you like. So, what's next? Obviously, we don't want to just show canned tweet data. We don't want to show the stub data that we've been publishing. We want to show real tweet data. I'm going to do this in normally 2 steps, but in this case, probably 1 step because we don't have that much time. What I've done is, because I don't trust the conference Wi-Fi, I'm not going to connect to the internet and try and get tweets from Twitter. Also, you never really know what you're going to see. So what I've done, I've downloaded an hour's worth of tweet data, and I've saved it into a file, and I have the file on my local system here, and I want to read that file. I'm going to publish that real tweet data, so that then we can create services which parse that real data and turn it into something on the UI. So this canned tweet service, let's take a look at this. This thing is quite fun because it uses a combination of Java 8 and Java 7 features. So if you're kind of in the group of people, then there's loads of them who are jumping from 6 through 8. You might have missed some Java 7 features. We'll have a look at some of these now. So we're going to use the Java 7 I/O features combined with, as I say, some Java 8 stuff. So we're going to use files.lines. So this is going to return me a stream of lines in the file that's in this file path. Now, I'm going to use, hold on a second. No. So this gives me a stream of lines. I'm going to use the try with resources to make sure everything's shut down properly after opening this file. I'm going to add a catch clause. I'm going to say, to do real error handling. Like we always do, right? It's like real life. And now, given these lines, what do I want to do? Well, I need to filter some stuff out, because in my file, I actually have occasional lines which just say the string OK, which I assume is just Twitter reporting back saying, you're still connected, everything's fine. So I want to make sure that I don't have that. So I'm going to filter out everything where S is equal to OK. What else? And then I'm going to... It turns out, which surprised me, that parsing a file is extremely fast, much faster than I expected, and a bit too fast for this demo. So what I'm going to do is I'm going to cheat enormously to make the demo really effective. And I'm going to use, I'm just going to add an artificial delay. So I'm going to add a sleep of 5 milliseconds into each one of these things, just to kind of stagger things out. The stub services are publishing every half a second. This is going to be publishing every 5 milliseconds, so it's still faster than the previous data. By the way, if I ever see anyone putting like a sleep in their production code, I will come and hunt you down, unless it's meant to be there. So let's have a look at this. So we are going to say, we'll add our artificial delay here. And then I'm using peek because peek kind of lets you have a look at what the state of things are in our stream at the moment. I'm not using my S1 parameter, but I'll show you why I'm using peek in a minute. So I can say, for each one of these, what I really want to do is I have a tweets endpoint. Endpoint. I'm going to pass this to the endpoint so it publishes it. And once again, you'll see I'm totally leaning on IntelliJ to help do my conversion to Java 8. I could have put the artificial delay in the for each and had it in a lambda with 2 lines. I've chosen to put it in peek so that if I want to get rid of it, I can just remove that line completely and it just goes away. It's just a purely, I guess, aesthetic choice on my part. So if I start running this service, Then I'll have another service at the back end, which is emitting real tweet data on a different port and different address. Up here, where has it gone? So it's running at 8081. So this is real tweet data being emitted on a different service. So now we're at the stage where we have this service. It's not connected to anything, but we have this service and it's emitting data. So what we want to do is now we want to replace our stub services with real services. So I'm going to have a real user service, and what this needs to do is take that real tweet data and pull out just the Twitter handle from that real tweet data. My user service turns out to be not really that much more complicated than my stub service. So I'm going to have a new service. It's obviously going to have, once again, the endpoint to connect to is user service. That's my tweet service. So I'm going to connect to the tweet service to consume the tweets so that I can parse them. I need to give it the endpoint, which is, I'm going to be users. I'm going to be at port 8083. I need a message handler, which is going to return a Twitter user. And I've got tweets parser, which will take that and get the Twitter handle from the full tweet. So my message here is full Twitter. So Twitter gives you like this JSON of like everything, the message and where it came from and the Twitter handle and stuff. And I have the new Twitter. Oh no! So I have a tweet parser which is going to get the Twitter handle from that as a string. I need to return a new Twitter user which uses that. And obviously I'm going to turn this into something Java 8 shaped. So this becomes a Lambda. So the business logic for my real user service is not that much more complicated than the business logic for my stub one. All it does is it takes the full Twitter message, hands it over to a parser, says, give me the Twitter handle, and then turn that into a real Twitter user. So if I stop my stub service, let's stop my stub service. Let's start the real user service. Let's restart the dashboard. And now we can see our Twitter handles are real Twitter handles, not our fake, like, 3-character things. And we can also see they're updating much, much faster because that data is coming through much faster than my stub service. Okay, so now we're connected to real tweet data with the real user service, which is doing the real parsing, and we're showing that on the UI. The last piece we need to do is create the mood service. Obviously, we've done the user service. So this is where we're going to replace our stub service with a mood service, which is going to analyze our tweets. Now, this is not quite as exciting as you think it's going to be, but, you know. So our mood service. It's a little bit more adventurous than the user service because I need to get the message, I need to analyze it for moods, and then I need to turn those moods into this comma-separated set of values that I'm going to emit. So I still need a new service. I still need to connect it to the Twitter service. I still need to publish this at moods and 8082, and I need to give it some sort of message handler. Here I have a mood analyzer. I'm going to call analyze mood with a full Twitter message. And the mood analyzer is going to obviously do the bulk of the business logic for this. So I'm going to replace that with a method reference. So obviously my service looks super tiny. What I need to do is I want to look into my analyze mood method to see how this works and implement this. So this is not any sort of like algorithmic learning or anything really exciting like that. I am going to take the Twitter message, I'm going to have a look at what words are in the Twitter message and do a really rough association with a happy mood or a sad mood. Okay? And obviously these are just English too, so this is like the crudest approximation of mood analysis you could get. So I can do my mood parser will allow me to get the message from the full Twitter JSON, and I can turn that into a string array. So then because I have a string array, I can do stream of this array, and I can do. What do I want to do? I want to map these. If you'll notice from my word to mood map, all of those words are lowercase. So I want to turn my words into lowercase. I want to also, I'm going to take that word and I want to search in my word to mood map to get the right mood out. So again, well, let's turn this into method reference. So I can say word to mood, get any mood that's associated with that word. Again, this can be replaced with a method reference. Now that might be null, because if the word is not in the map, then the value which comes back is going to be null. So let's filter out the nulls. So if I don't want where the mood is null. Oh. And finally, I'm going to collect these into a set, because I actually don't care how many happy words or how many sad words. I could, maybe that's a changing requirement, but I actually only care if it's happy or sad. So collectors.toSet. And so that's my set. So that's how I do my mood analysis. Given a sentence, how do I turn that into a set of moods from that sentence? There's one last thing we need to do. I said they were going to be in comma-separated values. So I've done the crudest thing that would work, and I'm going to override the toString method to turn this set of moods into a string which is happy or sad or comma-separated values. So we can use a different collector. Oh, every time I do this. We can use a different collector to do this. Now, this is the thing. This is one of those really simple little things that just gave me joy when I found it. Instead of having to write an iterator which goes through and puts a comma after every word, and then on the last one takes the last comma off because you don't need the comma on the last one, or perhaps does it the other way around because you're not really sure which way to do it, you can just give it a joining collector, and it will put commas between the values. You don't have to worry about any of that stuff. You just get a CSV set of values. It's fantastic. Lastly, I'm totally out of time, and I won't tell you that so you don't realise. I will start up my mood service. We'll stop the test service. We'll start up the real mood service. And then, no doubt, as always happens, the dashboard will not work at the last minute. Let's see. That's running. Restart the dashboard. Yeah, it's working. Yay. And you can tell it's using the real data because, weirdly, on a Saturday morning, most people were tweeting happy things. I was really amazed. So just to finish up, we managed to build up a fairly complicated architecture for the system using independent services that all listen to each other for messages. We're not going to do this bit. We don't have time. And also, I don't want to connect to the real internet because it's going to go wrong. So what we learned is how to use streams to manipulate data. So we saw streams when we were doing our leaderboard, how to reorder things. We saw streams when we were doing our mood analysis. So we used them to kind of take data, sometimes smoosh things together, sometimes just filter it and find out which bits are interesting to us. We saw where Lambdas might simplify your code, especially, obviously, you're going to use Lambdas in passing into streams, but you're also perhaps going to use Lambdas to pass bits of data around, bits of behavior around inside your own code. We also saw where Lambdas might not simplify your code, so you have to bear in mind some of those trade-offs. We also saw the basics of building a JavaFX UI. For me, so I'm not a JavaFX person, I found it quite easy to pick up, and it does all that animation kind of for free and out of the box. And of course, it's part of Java 8, so it is one of the big features of Java 8. All of the resources, the code, previous videos of this presentation, they're all at this URL here. So if you are interested in looking at the code, if you do want to have a look at the resources I used to build up this application, this includes links to books, articles and blogs on Java 8, on WebSockets, on JavaFX. There's loads of information there about how I basically created this application. I don't have any time for questions. I'm so sorry. I will be kicking around the conference for a very short period of time, so if you do have any questions, please come and grab me. Thank you very much.